Chapter 1.7.7 Resource Management for Windows Nodes. The text discusses the differences in resource management between Linux and Windows. In Linux, C groups are used as a pod boundary for resource control, with containers created within that boundary for isolation. Linux C group APIs gather CPU, I/O, and memory statistics. On the other hand, Windows uses job objects for process isolation with system namespace filtering. Windows containers require namespace filtering for security, resulting in no availability of privileged containers. Additionally, Windows containers cannot assume the identity of the host due to separate security account manager. Memory management. Windows does not have an out-of-memory process killer like Linux. In Windows, all user mode memory allocations are treated as virtual, with page files being mandatory. Windows nodes do not overcommit memory for processes, meaning it won't reach out-of-memory conditions as Linux does. Instead, processes page to disk when memory is exhausted. However, if memory is over-provisioned and physical memory is exhausted, paging can lead to performance slowdowns. CPU management. Windows operating system does not guarantee a minimum amount of CPU time for processes, but it can limit the amount allocated. The kubelet on Windows supports a command line flag called -shows Windows-priority class, which allows setting the scheduling priority of the kubelet process. By setting this flag to above normal priority class or higher, the kubelet process can receive more CPU time slices compared to other processes on the Windows host. This helps prevent running pods from starving the kubelet of CPU cycles. More information on allowable values and their meanings can be found at Windows Priority Classes. Resource reservation. To ensure optimal performance in a Kubernetes environment, it is important to reserve memory and CPU resources for the operating system, container runtime, and Kubernetes host processes using the -kube reserved and/or system reserved kubelet flags. These values are crucial for calculating a node's allocatable resources on Windows. When deploying workloads, it is advised to set resource memory and CPU limits on containers to avoid over-provisioning nodes and causing them to become unhealthy. A good practice on Windows is to reserve at least 2 GB of memory and to monitor CPU usage to determine the appropriate CPU reservation for each node based on workload needs.